Hello everyone, my name is Martin Linksfeld and I am Master Chef in FoggyKitchen.com. I'm not sure if you have noticed that, but in March 2021, Kubernetes cluster have been significantly redefined within OCI. I mean now container engine for Kubernetes is VCN-Native by default. VCN-Native clusters are completely integrated with your virtual cloud network, VCN, and you can make them private or public. Your cluster worker nodes and load balancers are already part of the VCN. You can add now the Kubernetes API endpoint to the VCN too. In this video, I'm planning to focus my attention on fully private use case where all three parts of Kubernetes are deployed in private subnets. So we will have private Kubernetes API endpoint, private worker nodes, and private load balancers. As you probably know, I am a big fan of the automation. Therefore, my deployment of private OKE will be done automatically with the usage of Terraform. I hope you'll find the recording useful in your current work and the future work as well. Before checking out our code, let's do a quick review of our topology diagram. As you can see, we have one OCI region here. Inside this region, we have 3 availability domains, but for the usage of our exercise, we will just use one availability domain 81. In this availability domain, we will have 3 fault domains. So elements of the infrastructure will be spread between 3 fault domains. And inside this infrastructure, inside this VCN, we'll have 4 subnets. Bastion subnet is only one public subnet, so we can access the Bastion host through from public internet, and we can use it internet gateway. The rest of our subnets are fully private. That's why we have not gateway here, right? So we have Kubernetes load balancer subnet, we have Kubernetes API endpoint subnet, and ultimately we have Kubernetes node pool subnet. And how we can access this infrastructure? Of course, we have here dynamic routing gateway, DRG, and we can connect that DRG to our on-premises installation, right, our data center, and we can use Fast Connect or VPN, right? So we can access this private infrastructure from on-premise data center. On the other hand, of course, we can go via Bastion host, and we can access private subnets through the Bastion host. Frankly speaking, in this video, we will use this green way to access the infrastructure. Okay, now we can move to our code. Okay, now I am in a local copy of my Terraform repository, and let me show you how the code looks like. I will start the journey from network.tf file. Inside this file, we'll find definition for a VCN, then DRG, and the attachment between VCN and DRG, right? DRG attachment. Next, we have a definition of service gateway. And this service gateway will be then used as one of the destination in a route table. But before then, let me show you NAT gateway. NAT gateway will be used for private subnets to connect to the internet. And here is a definition of the route table for private subnets, right? The first route tells that if you want to go into public internet, right, destination 0.0.0/0, you will go through the NAT gateway. If you want to reach services, OCI services, here you have another route rule which push the traffic directly into service gateway. Next, for a public subnet, for the Bastion subnet, as you will see, we will have Internet Gateway, right? And this Internet Gateway is visible also in a Internet Gateway route rule, right? So for a public subnet, if you want to go to the internet, right, 0.0.0/0, the route will push you into Internet Gateway. Then we have some definitions of security lists for each and every subnet. I will just scroll down because all of that you can read in a documentation. And ultimately, at the very end, we'll find definition for our subnets, right? I have mentioned we have private subnet for Kubernetes API endpoint. So it's here. As you can see, we have here prohibit public IP on VNIC set to true. So there won't be any public IP addresses associated with this subnet. As you can see, we are using route table via NAT to access internet. The same thing for LB, right? LB subnet, Kubernetes LB subnet, again, prohibit public IP on VNIC, again, route table via NAT, right? And finally, subnet for node pool for workers, and again, prohibit public IP on VNIC, and route table via NAT. For Bastion subnet, we have only one public subnet, and here there is no prohibition to set up public IPs on VNIC, and we will be using Internet Gateway to access internet. That's mostly all in terms of the network configuration. Let me go to the Bastion server for a sec. So Bastion server is nested, as I have mentioned, in a Bastion subnet. We will have public IP, assigned public IP. Of course, we have option to choose flex shapes, and that's why we have this dynamic block shape config here. Okay, that is all in regards to Bastion service. Bastion server, please let me go to OKE cluster. And what we have here, first of all, we need to have cluster itself, right? We can define the version of the Kubernetes. It will be nested in a VCN. And for private endpoint, we will have subnet also chosen, right? And as you can see here, we have an attribute is public IP enabled set to false, right? Meaning the private endpoint will be only private, right? And here we have also definition of our private subnet. In case of the load balancer, we have a section here, options, and inside this section we have service LB subnet IDs, and here we are defining just one subnet. And that is mostly all in regards to OKE cluster. Let me scroll down to node pool, right? So this node pool is of course associated with our cluster. We are also defining shapes for the nodes. Of course, we can use here flex shapes. Very important thing, ARM shapes will work only with the private VCN-Native Kubernetes cluster. So yeah, it's worth to know. And finally, as you can see for node config details, we have a placement config, and for subnet we are associating our Kubernetes node pool subnet. And that is mostly all necessary to run our code. And let me go now directly to my repository on GitHub. As you can see, I am now on GitHub in my public repository covering Terraform OCI private OKE scenario. Of course, we can use Terraform CLI, meaning we can download the code directly to our computer and we can play a little bit with Terraform. Here, for the purpose of this presentation, I will just use the magic button and I will use deploy to Oracle Cloud, which means essentially I will use Resource Manager, right? So now I am already authorized, so there is no question about my login and password. The only thing I need to do is to click on accepting terms and conditions, and my zip file with the stack will be downloaded directly into my tenancy. I will choose the compartment for our stack to be created. Then I will just click next, and I will choose the first availability domain in Frankfurt. How many Kubernetes nodes? Let's stay with 3, what is the default? Then I will click Show Advanced Options. I will choose the latest at the moment version of Kubernetes 1.19.7. In case of Kubernetes nodes, I will stay with E3 Flex, 6 gigs for memory, 1 gig for one OCPU. Then I will scroll down and I will paste my public key. For Bastion host, I will stay with E3 Flex and with 1 gig of memory and 1 OCPU. The rest will stay with the default values. Let me click next. I will scroll down. I will not run at the moment. I will run it later, and I will click on create, and within a second I think we will have our stack created. Let me run the plan, right? So I will click plan, and within some time we'll have plan ready for us. So let me wait for a sec. As you can see, plan job is done, so it's in green, succeed. Let me see what Terraform is planning to create. Okay, I'm scrolling down. As you can see, OKE cluster, and then OKE node pool, DRG attachment, and so on. A lot of elements. So let me scroll down to the very end of this long list. And what we see, we will have a plan to add 21 resources with Terraform Apply. Okay, we can move to Terraform Apply. I am again on the stack level, and let me click Terraform Apply. And within a few minutes, we should have all the infrastructure up and running. So let me wait for the first log entries here, and then I will pause for the time of the provisioning, right? Okay, let me click here, apply in progress. I can potentially reload the page just to speed up the output. Yeah, as you can see, the process is ongoing now. I have a Bastion service in a configuration and a provisioning. So let me pause this recording for a few minutes. Okay, as you can see, apply job is finished. It has taken some time to create cluster and the node pool. And let me go directly to network infrastructure just to see what we have here. I need to switch the compartment, and then into Foggy Kitchen compartment. As you can see, I have VCN, and inside this VCN I have one public subnet for Bastion and 3 private subnets for node pool, API endpoint of Kubernetes, and Kubernetes load balancer as well. Okay, now I can go directly to OKE itself, Okay, and as you can see, we have a cluster here, and yeah, and let me verify the node pools. Okay, so node pool is here, it's active, and I can immediately verify the nodes, and it looks like all of the nodes are ready. And that is all. And in case of the node pool, one thing to highlight, we have this private subnet here for node pool. Let me go again on a cluster level, and as you can see here, for Kubernetes API endpoint, we have a subnet, as you can see here, and one subnet for LB. And that is mostly all in case of our deployment. Okay, before destroying all of the infrastructure, let me show you how I can access Kubernetes pods and nodes directly from the Bastion service. First of all, I'm here on my Bastion server. I'm already prepared here, meaning I have installed kubectl, right? I have also OCI CLI pre-installed, so let me go directly to my cluster, and I will go to quick start. I have a first step, access your cluster. As you can see, usage of the Cloud Shell is blocked. Why? Because we are completely in a private infrastructure, right? So in that case, we can use, Bastion host, and this is well explained here, right? So first of all, let me verify what version of OCI do we have here. And yeah, 2.26.0, that's great. Let me build the proper directory for kubectl configuration. Okay, now I can copy the command to create VCN-Native private endpoint access. The access via VCN-Native private endpoint, right? So I'm executing this command. As you can see, permissions to home opc.oci config are too open, so let me, run this export just to, block this warning. And now I need to run also export for kubeconfig, and I can run kubectl get nodes, and I expect within a few seconds to see 3 nodes, right? Let me compare that with our nodes from node pool, right? So here we have nodes, and yeah, of course here we can see the node name, which is dynamically created, but let me click on that, and within a second I will be transferred to compute instance, right? Okay, private IP, do we have it? Yes, it's a first node, right? Last octet is 110, perfect. Okay, next what we can do, we can run kubectl get pods namespace kube system. That's right. As you can see, I can see all necessary pods required to run Kubernetes. Of course, there is no other pods, right? Because we haven't deployed anything so far. Yeah, So it will be just empty, right? No resources found in default namespace. But anyhow, I'm trying to tell you, everything has been configured and I can access the resources directly from my BASN server. Now I can return back to my console. I can go directly to the stacks and I can just destroy the infrastructure. So I will click destroy, and within a few minutes I will return back to showcase that everything has been destroyed from my tenancy. So I will pause now for a moment. As you can see, destroy job is finished, meaning all of the elements has been destroyed. I can verify to be fully sure. Let me go to developer services and Kubernetes. And I need to switch the compartment again. No resources. That's really great in case of the networking, virtual cloud network. Recently, I have had one VCN here with 4 subnets. Nothing like this is visible, so that's the sign that everything has been destroyed. And let me check the instances finally. And as you can see, BASN server terminated, and 3 compute nodes for OKE has been terminated as well. That's the signal. All of the infrastructure has been destroyed successfully. Because before closing this session, I would like to show you something more. So if you are interested, I think you should visit our Foggy Kitchen and see our courses. As you can see, we have 4 courses for different scopes. We have this how to automate OCI with Terraform, where you can learn how to build infrastructure. The curriculum is quite big. We are starting with single VCN subnet and a single web server. And through all the lessons in a row, you will learn more and more complicated configurations, including advanced topologies such as local peering, remote peering, usage data guard, and transit VCN. Also, you can learn about flexible infrastructure in the second course, right? In this course, you will see how it is easy to use OCI flexible load balancer, how you can modify VCNs and subnets, how you can use BASN service, and many others, other flexible options inside OCI. We have also a course covering Resource Manager fundamentals and the course for ATP, so around autonomous database offering. All of those courses are available for self-study, and I really encourage you to try. And that is all for today. Thank you and see you soon.